Hi everyone, my name is Reyhan and I'm from Team 2. The project that we chose was the TA allocation management system, and along with me we have Shan, Varun, Aadil, Devstutya, Ariana, and Naman. Going into the details of our project, our system simplifies the TA allocation process at UBCO by replacing some of the manual workflow that Chat deals with an integrated platform. It supports three roles: students applying for the positions, that's a student, and also they have the option to view their offers. Instructors give preferences for their courses and view allocations. And lastly, the third user, that is the TA scheduler or coordinator, who handle the allocation and scheduling. Some of the key functional requirements for this project that we came up with for the three different users are as follows. For the student, they're able to create an account and profile, upload resume and transcript, apply to the positions and track status, accept, decline, TA offers, view the schedule in the calendar, and also update their availability. When it comes to instructors, they're able to submit course preferences, view and export assigned TAs, view TA availability, and finally, for TA coordinators/schedulers, they are able to manage courses and postings, import, export historical data, and also assign and reassign TAs, track availability/conflicts, and finally visualize the allocations. Some of the key non-functional requirements are as follows. Data privacy, we focus on encryption, access control, and secure uploads for whatever files they're uploading, especially transcript data. Responsive UI, work on all screen sizes, modular architecture for scalability, and for further development. Security best practices when it comes to SQL injection protection and also JWT auth. Cross-platform compatibility, we're going to build this project with Docker for smooth deployment, CI/CD pipeline automation, and also clean merges. And finally, role-based access, permission controls for each user type. Moving on.
Hello everyone, I'm Varun and I'll be going over the system architecture. So for our system architecture, we have gone with a hybrid monolith microservice architecture to maintain a scalable, modular, and a maintainable software while ensuring ease of development. Our architecture consists of four main parts, which will be our client, reverse proxy, a microservice layer, and a database. Our client will be a React-based front end with Tail and CSS, which will provide dashboards for each user type and their specific needs. Going forward, we have a reverse proxy, which will be serving as a bridge between front-end requests and back-end services, while also providing features such as logging and security. Next, for our backend, we have a layer of microservices. Here, each unique functionality is split into its own little program and will be run in isolation, which will then be integrated by the reverse proxy and ensure this functionality is given to the user in the front end. Lastly, we have a unified PostgreSQL database. This is done instead of using multiple databases as required in microservices to ensure quick and easy data retrieval and storage, along with reducing schema duplication.
Hi, I'm Ariana. I'll be talking about use cases. So we identified three user types: the student, the TA scheduler or coordinator, and the instructor. Overall, we outlined login as being common functionality for pretty much every use case. And then we also outlined a commonality between importing historical data and allocating TAs to courses for the TA scheduler. For the student, we have create account, apply for a position, act on an offer, and view assignments / their schedule. For the instructor, we have view assigned TAs and specify preferred qualifications for those TAs. Then for the scheduler, we have import historical data, allocate TAs to courses, manage course offerings, and visualize allocations. Onto the use case descriptions. First use case I'll talk about is apply for position, where the primary actor is the student. Students can apply to TA for a given application period, inputting the required documents and data, and their preferences in terms of how many hours they want and courses. Preconditions are that the student is logged in, that there exists an active application period, and that the student has not already applied for that application period. Now for the scenario, from their dashboard, the student selects apply. They then answer the application questions, input their availability, set their preferred number of hours for each semester. Then the student can look through the courses and indicate which ones they'd like to be considered for. They can then upload the required documents, which consist of a resume and a transcript. Then the student submits, and they're redirected to their dashboard where they can see their application status. The second use case I'll talk about is manage course offerings, where the primary actor is the TA coordinator. The TA coordinator can create and manage course offerings within a given application period, along with details like lab sections, instructors, and how many TAs that course offering gets. Preconditions are that the TA coordinator is logged in, and that they have a file which contains course offerings for the period they wish to update, and it's in the correct format. This is if they want to bulk add courses. Postconditions are that the course offering information is updated, stored, and displayed. Now for the scenario. So the TA coordinator selects course offerings option from their dashboard. They indicate the the application period they want to manage. From there, the coordinator has the option to either bulk add or manually add one by one. For bulk add, the coordinator uploads their file and then the system validates it. For manual, the coordinator selects the existing course offering they want to modify, or they can add a new one. Then they configure the details. For either option, the coordinator will take a moment to review what they've done, make sure it's correct, then they submit, and the system displays a success message.
Hi, I'm Aadil. I'll be talking about the DFT level 1 diagram. So as you can see, we mainly have three users, the TA scheduler, student, and the instructor. We also have the processes that they go through in the application and also the data stores which are used. So in this level 1 diagram, we go into more detail with respect to the TA system itself. Several processes are specified such as register student, update profile, browse/apply, TA positions, etc. There are also the data stores in the diagram, which are labeled according to what data it contains exactly. It also shows what data exactly flows between the data stores, system processes, and the users. So between all three of them.
Hi, I'm Shan, and I'll be talking about the ERD. To create our ERD, we went through our requirements and identified key concepts which we modeled as relational entities. Some key concepts, of course, include students, courses, course offerings, etc. But for the sake of time, we're going to focus on two main core concepts that are really important to the system: that of applications and allocations, and we have them here in our diagram. So for application, a student will create an application in response to a job posting. Um, a student can have multiple applications. So there's a one-to-many relationship between these two entities. Also, according to our requirements, an application can be submitted for multiple courses. So an application will share many-to-many relationship with the course offering, and we manage that using a bridge table called application selected courses. In terms of allocation, so we envision it as TA scheduler providing an offer to a student, and if the student accepts that offer, then that results in a formal assignment. Now we've modeled the offer here, and an offer is connected to one student. This reflects the application student's application, and we'll have details about the position and the and what's being offered. An offer can have one or zero assignment. It just depends. If the student accepts the offer, then there is an assignment. If the student declines the offer, then there is no assignment. Now, assignments are then also linked to shift. Shift will capture information such as what the student is doing on a daily basis. And that's it for me. I'll turn it over to.
Hey, I'm Naman. So I'll be discussing the design choice that we had for the system. So for the design of our system, we started by first creating the ER diagram. Our goal was to understand and model the core data structure, what entities would we need and how they would relate to one another. Also how we could maintain data integrity across various roles and processes. I think this helped us define important entities in our system. Now through multiple iterations, we again define the schema to ensure normalization, handle the relationships, and support key functions like tracking applications. Once we had the solid ER diagram, we moved then into designing the data flow diagrams. Then level 0 gave us a high level view of how external users interact with the system. And from there on, we level 1 broke down internal processes like student registration and stuff like that. We chose this design path starting with data modeling first because it gave us a clear understanding for the system, and it ensured that our logic was grounded in a consistent schema. As a team, we found this approach made it easier to catch inconsistency early and also gave us confidence that our system would scale well and maintain it.
Hi, I'm Dave, and I'll be walking you through some initial UI mockups we've created. Firstly, here is the TA scheduler dashboard. It's a main command center for TA allocation. We've opted for a clean and learnable UI design. For the TA scheduler, we have an active competition section, which is synonymous to application periods, and this will group a variety of course information for specific terms or semesters together. If the TA scheduler clicks Manage on any terms competition or application period, they'll be viewing courses, openings, instructors, etc. for that specific term. The quick start section is a key innovation. It provides metrics like courses that require deallocations and applications in need of review. We've also added an actions sidebar, which helps separate major functions and simplify complex workflows. Moving on, next is our managed course offerings interface for the TA scheduler. This demonstrates our bulk data management capabilities. The coordinator can view all courses in a filterable table format with the semester, course codes, sections, and TA requirements clearly displayed. What's unique here is our integrated approach. As you can see, instructor names, TA needs, edit, delete the functionality, all these options in one view. The search and filter functionality by semester and subject means coordinators can also have an easier time navigating through hundreds of course offerings. Finally, the student dashboard shows our user-centric design for applicants. The quick info section displays key profile details and application deadlines. The My Application section is particularly thoughtful as it shows courses applied with the student status. Students can see the requested hours, referred courses, and application progress all in one place. The My Schedule calendar view at the bottom allows students to see their weekly commitments in a familiar calendar format, making it easy for them to understand their weekly time allocation. And to finally close things off in the summary and testing criteria, we're building towards a stable MVP by June 27th. Each feature will be tested individually and integrated via CI/CD, and the code will be passed through a peer review, and we're tracking the code coverage through automated pipelines. Thank you.